Hello everyone, welcome back to our chemistry class. So we are still in chapter 4, chemical bonding. So this video is about part C, Lewis structure, where we will learn how to write the Lewis structure for covalent bond. There are a total of 5 steps in writing the Lewis structure for covalent bond. The first one, you need to calculate the total valence electron of all atoms, and you need to plus the charge of molecules if any present. Second one, you need to draw the skeletal structure for the molecules, and please take note that the central atom must be the least electronegative atom except H, hydrogen. The third one, you need to put a single bond between the central atoms and the terminal atoms. Okay, and then the fourth one, you need to put a valence electron on terminal atoms so that the terminal atoms can achieve octet. If there is remaining electrons left, the electrons will be put to the central atom. And the last one, if the central atom is not octet yet, double bond or triple bond will be added by moving the lone pair from the terminal atoms. So let's take a look at a few examples. The first example, we need to draw the Lewis structure for NF3. Okay, so the first step, we need to calculate the total valence electron TVE for all atoms. So when we calculate, there is 1 atom N and 3 atom F. Okay, and then when we calculate the total valence electron, we get that there is a total of 26 electron in the molecule. Okay, the second step, we need to draw the skeletal structure of the molecules. So when we compare N and F, okay, N will be least electronegative than F. So N will be the central atom, while F will be the terminal atom. So there is 3 single bond there with total of 6 electron. So we minus 6 from the total valence electron. So we have 20 electrons left. Okay, so the next step, we need to put the valence electron on the terminal atom so that the terminal atom can achieve octet. So each of that fluorine atom will have 6 valence electron put there. So the total electron used until now is 18 electron. So there is balance remaining 2 electron. So this remaining electron will be put on the central atom. Okay, so we already used up all the total valence electron, and now for the final step, we need to check that the central atom is octet or not. So when we calculate, the central atom is already achieved octet. So our Lewis structure for NF3 is already settled. We will repeat the same step for the second example, example 2. So we calculate the total valence electron for CH4. So we have 1 atom carbon and 4 atom hydrogen. So the total valence electron for CH4 is 8 electron. Okay, and then we draw the skeletal structure. C will become the central atom. Okay, sebab H tidak akan jadi central atom. So we already use up 8 electron for drawing the skeletal structure. Okay, so we already use up all the valence electron. And then when we check the carbon also already achieved octet. So we already settle for example 2. Next, for example 3. Okay, for example 3, we calculate the total valence electron first. So we have 2 hydrogen atom and 1 oxygen atom. So when we calculate the total valence electron, we get that there is total of 8 electron. Okay, valence electron in the molecule of water. Next, let's draw the skeletal structure for water. So O, oxygen atom, will become the central atom. Okay, so we are using 4 electron to draw the skeletal structure, and we are left with 4 electron. But please bear in mind, hydrogen already achieved octet or duplet, so it's already stable. So the remaining electron will be put on the central atom. Okay, so we already used up all the valence electron. So when we check the central atom, it's also already achieved octet. So we are done for example 3. Next, for example 4, same thing. We calculate the total valence electron. We have 3 atoms here, hydrogen, carbon, and also nitrogen. So the total valence electron for this molecule is 10 electron. To draw the skeletal structure next, we need to decide which one will be the central atom. So the central atom will be the atom that have the least electronegativity. H will not become the central atom, so we need to compare carbon and nitrogen. So carbon is the least electronegativity atom, so carbon will become the central atom. So we draw the skeletal structure. Okay, and when we draw the skeletal structure, we already use up 4 electron. So we have 6 electron remaining. Okay, please bear in mind, hydrogen already achieved octet. So we need to put the 6 electron on the nitrogen atom. So we already used up all the total valence electron. And then next, when we check for the carbon, we can see that carbon only have 4 electrons there, meaning to say carbon still not achieve octet. Carbon as central atom is not octet. So what we can do is we need to move the lone pair from the terminal atoms to form another bond. So the new structure will become like that. But when we check again for carbon as central atom, carbon is not octet yet. So what we can do is we repeat the same step. We move lone pair from the terminal atoms to form another single bond. And then when we draw the new Lewis structure, okay, we can get like that. And we check again for carbon as central atom. And this time carbon is already achieving octet. So this is the Lewis structure for HCN. Next, for carbon dioxide, we repeat the same step. We calculate the total valence electron first. We have 1 atom carbon and 2 atom oxygen. So the total of valence electron will be 16 electron. Okay. Now, let's draw the skeletal structure for Ca2. So in this molecule, carbon will become the central atom because it is least electronegativity. So we use up 4 electrons, so there is balance of 12 electrons. So these 12 electrons will be put on the terminal atom so that the terminal atoms can achieve octet. So when we do this, we already use up all the total valence electron. Okay, the next step, what we must do, we need to check whether the central atom reach octet or not. So it does not achieve octet. So what we can do is we need to move the lone pair from the terminal atom so that it will form a new bond. Okay, when we move from the left and also from the right oxygen atom punya lone pair, we get the structure like that. So when we calculate the number of electron in the central atom, meaning to say carbon already octet. Okay, ataupun itu lone pair kita boleh gerakkan daripada satu oxygen atom sahaja, macam begini. Okay, dan bila kamu draw itu carbon dioxide punya molekul, kamu akan dapat begini. Okay, so meaning to say Lewis structure for carbon dioxide ada 2. So macam mana kita mau decide which one is the best Lewis structure? Nanti kita akan tengok dalam part yang seterusnya. Next, for example 6, kita ada ion karbonat di situ, karbonat ion. So sama juga, we calculate the total valence electron. So when we calculate the total valence electron, kita ada 1 atom carbon dan 3 atom oksigen. And then kalau kamu tengok di sana dia ada charge kan, 2 minus. Maksudnya, okay, dia charge negatif kan? So meaning to say the electron is accepted ataupun the electron is added into the molecule. So bila dia accepted, dia added, charge itu kita akan jadi +2 bila kita kira total valence electron. So the total valence electron for this ion is 24. Next kita draw the Lewis structure. So carbon will be the central atom. So we already use up 6 electron here with valence of 18 electron. So kita letak 6 elektron pada setiap terminal atom. Okay, so bila kita letak 6 elektron pada setiap terminal atom, so kita sudah guna ke semuanya valence elektron. Okay, sekarang kita cek pula central atom, dia octet atau tidak. Tapi central atom kamu tidak octet. So apa yang kamu boleh buat? Kamu kena move itu lone pair daripada terminal atom to form another bond. Okay, so bila kamu move daripada oxygen atom itu, lone pair akan hilang dan a new bond will be formed. So bila kita cek pada central atom sudah capai octet. Jangan lupa sebab dia ion, dia polyatomic ion, kamu kena letakkan dia dalam bracket dan charge dia adalah 2 minus. So apa kata kamu cuba buat sendiri example 7, pause this video and then I'll show you the answer right after this. So ini adalah jawapan untuk example 7. So good job on getting it right. Next for the last example, example 8. Okay, so kita kira total valence electron dulu bagi ion NO2+. So the total valence electron, sebab dia ada charge di sana dan kamu tengok betul-betul charge itu adalah positif. So bila dia charge positif, maksudnya the electron is being removed. Okay, jadi pada bahagian kiraan total valence electron, sebab electron is being removed, so dia akan jadi -1. The charge will be -1. So the total valence electron for this ion will be 16 electron. Okay, next we draw the skeletal structure for this ion. Nitrogen will become the central atom sebab dia least electronegative daripada oxygen. So we use up already 4 electrons and we have the valence of 12 electrons. So 12 elektron ini kita letakkan pada terminal atom. So what we do next, okay, because we already use up all the total valence electron, we need to check at the central atom, and then when we look at the central atom, we can see that it is not octet yet. So what we do next, kita kena move lone pair from the terminal atoms. So meaning to say kita kena gerakkan 2 pasang lone pair. Okay, so kita akan dapat structure yang ini. And then bila kita cek semula dia sudah capai octet dan ini adalah structure Lewis structure bagi polyatomic ion ini. Ataupun kita gerakkan 2 pasang lone pair daripada atom oksigen yang sama. Okay, so kita akan dapat Lewis structure bagi atom ini sebagai ini. Okay, so meaning to say untuk example 8 ini kita ada 2 possibility Lewis structure bagi polyatomic ion NO2+. plus. So macam mana kita mau tentukan yang mana satu adalah yang terbaik, kita akan bincang dalam video yang seterusnya. So itu sahaja untuk video kali ini. So kita akan sambung dalam video yang seterusnya. I'll see you in a moment. Take care and bye-bye.